Okie dokie. Keeping with the theme of mystery and things that some students find a little tricky, we're going to be talking about standing waves, which is the last of our major topics with waves, but I know some students find it tricky. We're doing okay for time, so perhaps we'll have a go properly at our exam question. Waves, they can be longitudinal or transverse. We've talked about that already, but they can also be classified into progressive, and all the waves we've talked about so far are progressive. The energy that they propagate does actually move somewhere. You know, signalman sends a wave from point A, the energy arrives at point B. Good. Alternatively, they can be stationary or standing waves, which don't propagate energy or information at all, and so are, less useful, practically speaking, but also useful to know in terms of generating music on a string. Progressive waves transfer energy or information in the direction of the wave, so they transfer information along a string. So if I have an unbound string, so I tell you what, if I have a piece of rope and it's fixed to a wall, I can do those battle ropes like at the gym, and I'll be propagating some progressive waves along the rope. If I do it hard enough, I guess, or if I have somebody at the other end also doing the same, our waves will approach each other, and in certain cases they can end up cancelling each other out at certain points, and that's when we can get the stationary wave. No net energy transfer. I have points with zero amplitude called nodes. So progressive wave, the energy is being transferred, and there aren't any fixed nodes. All the points at some point will deviate from this equilibrium line. Stationary wave, standing. You will get, if the rope that was drawn there at the start is what the rope looks like at one point in time, at the next it will follow my red line, but you will have these nodes where the rope just never moves. It's fixed as if somebody is holding it there. You also have these points where they are moving maximally, where they're going from extreme maximum to extreme minimum and back again. Those are antinodes. Fab. So standing waves, they are formed once again by interference, our old friend, and it's the superposition of two waves that are coherent. So in my previous example, I had two people generating them. If they do it very carefully and they try and match each other as best they can in terms of frequency, then they can form a standing wave. Another way, perhaps easier to do it, is to use a progressive wave against a barrier, and then the reflection of that self-same wave will interfere with a continuing original signal. Okay, and that way you guarantee it's coherent because it's the same wave, just at different points in time. These waves must have the same frequency and velocity, and they must be traveling in opposite directions. Frequency, so the driving, whatever source is driving these waves has to be going at the same frequency. Velocity will also somewhat depend on the driving force. It'll also depend on the medium. And they'll be traveling in opposite directions. This results in a waveform with fixed nodes. And these patterns, where you have fixed nodes, are called harmonics. You can say you've got the first harmonic and the second harmonic, and so on and so forth. Blah, 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 blah. If you're asked to define a node, it's a point of zero displacement in a stationary wave, antinode, a point of maximum displacement on a stationary wave. Okay, yeah, we're still doing fine for time. So let's have, is this a good question to have a go at? Yeah, go ahead. Spend a minute or two. This is a 3-mark question. So you'd have perhaps a little more time, but just have a think about how you would answer this. Microwaves are analyzed by reflecting them off a perpendicular surface a certain distance away. Explain how this process can form a standing wave. Okay. From the first word, you know it's something to do with waves. As soon as they talk about reflecting them off a perpendicular surface, maybe you're getting a hint of a stationary wave. But if that didn't prove it, the last one did. It's explain question. So I'm expecting 3 points in bullet point format. And our answer should describe the phenomenon of standing waves in the context given. It's a fairly abstract context, to be fair. Microwaves, it's not like a guitar string. So just have a think about how you would answer that, and maybe even jot down like a few words. And then don't worry too much if you get it wrong. As I say, reminder, we'll be sending out all these answers at the end of the day. Grab a drink of water. Right, let's have a look. So the reflection causes the microwave to travel back on itself, and it'll have the same velocity and the same frequency. The same frequency and wavelength indeed, because remember our wave equation. Velocity is equal to frequency and times wavelength. So if these two are the same anyway, then this is also going to be the same. All 3 are equal. They'll interfere. The microwave will superpose upon itself. And if the surface is the correct distance away, both waves will have points of constant phase and antiphase and form a stationary wave. I like this. It's got nice technical language. Without necessarily being, you don't have to be pretentious to use technical language. It's not too complicated as an answer. I like how straightforward it is. Hopefully